my name is Nick Ingram. Welcome to my 4C demo. So today we're going to be talking about CSOP form and CPOS form, as well as their standard counterparts. So first up is the canonical sum of product form. This includes every domain variable present in each min term. So the min term is product terms using the AND operator, and it contains every input variable. The way that we could kind of think of min term versus max term is min term gives about the minimum amount of space between each variable. So you could see right here, not A, not B, and C is ANDed together, and between that is an OR operator, and then you could see not A, B, and C ANDed together again, and the OR symbol, as well as not A, not B, and not C. So it creates a much more concise equation. It's also just a little bit easier to read straight from the truth table because it's not simplified quite yet, and we'll get into that in the next slide. But you can see here we also have CPOS form, or canonical product of sum form. This contains every variable present in each max term. So a max term is the sum of terms using the OR operator. It's much longer, so you could think of it as the maximum amount of space between each variable. And you can see it's kind of the opposite as above with that canonical sum of product form. Each variable is separated by an OR operator instead, and then each smaller part of the equation is connected by an AND operator. Kind of going into SOP and POS form, we first have to talk about standard form. Standard form, it's much more simple than canonical forms. Really, we've just reduced and simplified the equation using Boolean algebra, and it takes away a couple of the variables as well. Really, this is more readable, and it's also easier to transfer it to a circuit as opposed to reading it straight from the truth table. A good example is right here. This is actually Q equals XZ plus X not Y. That's our standard form for that equation. You can see it's much more concise than our canonical form, and it's much more readable. You can just basically slap that onto some schematics for a circuit, and you're good to go. For canonical form, not so much. Now, if we were to expand from SOP to canonical SOP, we would identify a term that's missing from the variable, multiply it with that term along with its OR operator and the complement, and then we simplify it from there. So we'll take X equals not A and C or B, and then we basically fill in not A and C and AND it with regular B or not B, and then we do the same thing for the second portion, and then we get this this big long portion of variables, and that is our canonical form. Now from POS to canonical POS, we're kind of working a little bit differently. We're adding the missing term with AND in its complement, so it's a little bit more different, but still kind of the same concept. So if we were to work with, X equals not A or C and B or C, we would really add in that B and not B right there, as well as the A and not A, because those are missing variables. And then we would expand them to kind of factor out those two B's right here, the B and the not B, and then the A and the not A. So we would turn out with not A or B or C, not A or B or not B or C, and then have these last two. You can see right here that we actually have the same. So we have a not A or B or C and a not A or B or C up here as well. So we would really just kind of cut out that extra fat, that dead weight, and then we would go with not A or B or C, not A or B or not B or C, and A or B or C. And really, that's about it. So thanks for joining me while I'm discussing canonical and standard forms, and hope you learned something new.